In this video, we're going to go over perimeter and area of similar figures. We're going to begin with ratios. Corresponding sides, so in the same spot on the figures, of similar figures are going to be proportional. The relationship between the lengths of your corresponding sides in the two figures is called your scale factor. The perimeter and areas are going to be related by the scale factor. Consider your units when coming up with the ratios. We'll talk about what that means here in a second. So we have our scale factor, which is going to be B to A. And if you recall from our similar triangle unit, we talked about scale factor being our new divided by our old. Then we have our similarity ratio. So our similarity ratio is going to be our A to our B, which is going to be our old to our new. And this similarity ratio has a lot of other names, such as, for example, here we have our ratio of our perimeters. They might also call it your side length ratio. It's still that A to B. So as I mentioned earlier, we're going to come back to the units part. Think about your side lengths, your perimeter. With those units, it's always centimeters, inches, feet, units. But when we start to talk about area, so here, for example, our area ratios, our units become squared. It's our A squared to our B squared for that ratio. Okay, so like I said, consider the units to tell you which ratio you want to be dealing with to solve. So let's look at number 1. So it's telling us here that the triangles at the right are going to be similar. Part A is asking for us to find the ratio from the larger to the smaller of the perimeters. So when I look over here and I see that I have a side length of 4 in my small triangle and a side length of 5 in my big triangle, I'm unable to figure out my perimeter, because perimeter would need me to add up all of my sides, and I don't know that all of my sides are equal. But that's okay, because if we're using our ratio, our perimeter ratio is the same as our side length ratio. Now, here, they tell us specifically the order they want it in. They said larger, which would be the 5, to the smaller, the 4. If they didn't mention that, and they just asked for our ratio of perimeters, the way you determine your A would be your A is the first one. So if you are reading from top to bottom, for example here, then this one would be my A, and this one would be my B. Now, if you had a picture where it was maybe from left to right, so I'm just going to draw you a visual here. So for example, this triangle to this triangle, your first one, so A, and then your second one would be the B. So just consider the order in which you come across them for your A and your B if they don't specify. Once again, in this problem, they did. They said the larger, so that would be my 5 to my smaller, which is the 4. So you can write this as 5 to 4, or if you would like, you may write it as a fraction. It is completely up to you. Now, key thing, and so the fraction might be helpful here, is make sure you always reduce. Here, I cannot reduce any, but in some problems you might be able to, and that reduced answer, that reduced ratio, would be your final answer. Okay, moving into part B here, we have if the perimeter of the smaller triangle is 18 centimeters, we are asked to find the perimeter of the larger triangle. So since we are trying to find the perimeter, and once again, you are unable to actually find perimeter, we are going to use the ratios. So I'm going to use that perimeter ratio I found earlier, and I'm going to set it equal to the perimeters that we are either trying to find or are given. So here the smaller one is 18 centimeters. Well, since it is the smaller one, I need to have it level with the smaller number from my ratio. So that was the 4, which I put in the denominator. So I'm going to put the 18 in the denominator. Then I'm going to say x here to have that space filled. There's a lot of different things you can call that, but since I am just being very vague, I'm calling it x. I would say we need to define it. So I'm going to say let x equal, and we can just say big P. P stands for perimeter. Okay. Another way could be you would do P with the subscript of a B to show that it is the bigger perimeter. And if you use that in your proportions, you would not need to define your variable. It is already defined with the fact that you're specifying it's the bigger perimeter. So it's up to you. Once I've done that, I'm now going to cross multiply. So I'm going to multiply the 4 and the x, and I'm going to set that equal to me multiplying the 5 times 18. Now, here, you can sit here and you can multiply, or I can go ahead and divide that 4 over to get that 5 times 18 divided by 4. And then I can simplify. So here I see the 18 and the 4 are going to both be divisible by 2. So I'm going to divide them to get 9 in the numerator and 2 in the denominator. Here I have nothing else to simplify, so I'm going to go ahead and multiply the 5 times the 9 to get 45, and then I'll have that over 2 centimeters. If you would like to change this into a decimal, you're more than welcome to. Keep in mind, you cannot round, so if it's not exact, just go ahead and leave it as the fraction. So that's why I'm going to leave it as a fraction. But like I said, you are more than welcome to write it as a decimal. Moving into part C, we have find the ratio of the larger, once again, to the smaller of the areas. So once again, keep in mind your areas are squared, your units are. Therefore, we should be dealing with our A and our B squared. So 5 squared and 4 squared. Make sure you actually square them to get 25 to 16. Or once again, if you would like, you may write this as 25 over 16, a fraction. Just a hint, if you are using the simplified ratio of A and B, when you square it, you should already have a simplified ratio. Okay? If you are using the unsimplified and you square it, then you will have to reduce. It should simplify after. Moving into part D. If the area of the larger triangle is 410 centimeters squared, we're asked to find the area of the smaller triangle. So since I'm dealing with area, I'm going to use my area ratio, which was that 25 over 16, is going to be equal, and I'm going to set up my fraction on the right side using that 410, which is the larger. So I need it to be in the numerator since that 25 is larger than 16. And once again, I'm just going to call this x and just define it to say, let x equal the small area. I'm going to use just a capital A for that. Once I've done that, I can then cross multiply to solve. So cross multiplying, I'm going to get 25x is equal to 410 times 16. Keeping in mind you can multiply or you may simplify. So here I'm going to show my division so that I can see which numbers I need to reduce. Here I see that 410 and 25 are both divisible by 5. So I'm going to get 82 times 16 over 5. Now make sure you are multiplying the 82 times the 16. And so when I do that, I'm going to get 1,312 over 5. Then I'll have my units, so centimeters squared. Once again, you are more than welcome to write this as a decimal. Once again, it just needs to be an exact. So if you're having to round, then you will lose points. All right, let's move on to number 2. Number 2, the ratio of the lengths of the corresponding sides of two regular octagons is going to be 8:3. The area of we have the larger octagon, is going to be 320 feet squared. We're going to find the area of the smaller octagon. So once again, since we are finding the area, I need to deal with the area ratio. Currently, I have that A to B, which is going to be that 8:3 that they gave us. But since I need area, I'm going to use A squared to B squared, which means I'm going to be using 8 squared and 3 squared, which this will just simplify to give me 64 to 9. So now that I have my area ratio, I'm going to just write 9 over 64 is going to be equal. And so I'm going to set up the other fraction using the area I actually know, which is the larger one. So looking over here, my 64 is larger. I place that in the denominator. So I need my 320 in the denominator, and I'll put x in my numerator. Okay, I'm going to let my x equal to the area of the small. And now I can cross multiply to solve. So I will get 64x is equal to 9 times 320. I'm going to divide by that 64. Okay, and so here I'm going to see what I can reduce by. So I see that 320 and that 64, I know that they are both divisible by 8. So I'm going to divide them by 8 to get 9 times that. We'll have 40 over 8. Now here I notice that maybe I didn't fully reduce. Okay, I didn't find the greatest common factor. And so I can then still keep reducing. And I would then just end up with 9 times 5, because that 40 divided by 8 gives me 5. So that's going to give me that my x here is going to be equal to 45. And then we are going to have our units. Let's scroll over. We got feet squared. All right, let's move into the next problem. We have Benita plants the same crop in 2 rectangular fields, each with side lengths in the ratio of 2:3. Each of the dimensions of the larger field is going to be 3.5 times the dimension of the smaller field. Seeding the smaller field is going to cost, we have $8. I want to know how much money does seeding the larger field cost. So right off the bat, there were two ratios that was provided. There was the 2:3, which was talking about my side lengths. And then there was that the dimensions of the larger from the smaller is going to be 3.5 times larger. So with that being said, we need to, for our ratios, our A and our B, compare from one figure to another, not from one dimension to another dimension in the same figure. So for example here, if I was dealing with a rectangle, that 2:3 ratio that they provided you with would be like this side being 3 and this side being 2. But that's within the same figure, so that ratio doesn't help me. And so I'm going to focus on using the, well, I can erase this, the 3.5 times larger ratio. So here, since it's 3.5 times larger, that's like saying 1 to 3.5. Now, personally, I don't like dealing with that fraction. So what I'm going to do here is I'm going to multiply both my A and my B by 2, and I'm going to get a 2:7 ratio. Now, keep in mind, if you don't know what seeding is, that's going to be you plotting those seeds on the inside of the field, which is considered area. So since seeding is dealing with the area, I want my area ratio. So I need to take that 2:7 ratio that I found, and I need to square it so that I can find my area ratio. So I'm going to deal with 4:49 as the area ratio. So I'm going to come over here. We're going to set up our proportion using that 4/49. And we're going to set it equal to the $8 for the smaller, which goes in the numerator because 4 is smaller than 49. And then I'm going to say over X. Before I move on, I need to make sure that I define my X so that I don't forget. And I'm going to let X equal the larger cost. Now I'm going to cross multiply, and I'm going to get 4x is equal to 8 times 49. And then, like I said, I like to go ahead and set up that division so I can just try and see what I can simplify before I have to multiply. So looking at what I currently have here, I can see that the 8 and the 4 will reduce. 8 divided by 4 is going to give me 2. And then I'm going to multiply it by the 49. And so 2 times 49 is going to give me a cost of $98. All right, moving into our last problem for these notes, number 4. The area of two similar polygons is going to be 32 inches and 72 inches. If the perimeter of the smaller polygon is going to be 15 inches, I want to find the perimeter of the larger polygon. So I need to set up a ratio, and looking at what I have, I currently am given areas. So noticing here that my inches are squared, I'm dealing with the A squared to the B squared. And just a common mistake, when I plug this in, make sure you are not squaring that 32 and 72. Looking at their units, notice that they are already squared, so that is your A squared and that is your B squared. And what's going to be very helpful here is to reduce. If you reduce, you are probably going to get some nicer numbers to then take the square root of. Why am I square rooting? Well, remember, I'm currently in a squared to b squared. But when I think about perimeter and I look over here at my units for perimeter, they are not squared. So I need to go from a squared to an a. In order to do that, I square root. So here I'm going to reduce, and when I reduce, I'm going to get 4 to 9. Well, in order to find my a and my b, I'm going to take that 4 and that 9 squared. I'm going to square root, each one of them. To get my a and b are going to be 2 to 3. So that's going to be the ratio I'm going to use to set up my proportions and solve for my missing perimeter. So setting it equal, I need to real quick, let me see, it was 15. Okay, so I've got that the smaller perimeter is 15, so that's going to go in my numerator since I have the smaller number in the ratio on top, over x, and I'm going to let x equal the larger p for perimeter. All right, cross multiplying, you should get 2x is going to be equal to that 3 times 15. I'm going to do my division here to get 3 times 15 over 2. I notice that neither 3 or 15 is divisible by 2, so I'm going to go ahead and multiply them together, and I'm going to get 45 over 2 inches as my final answer. All right, hopefully this video helped clear up anything that you were struggling with for our perimeter and areas of similar figures.